So, well, I had just introduced myself, and I was about to say that, I mean, I've been involved in a few things over the year, but this is the work of many others. I'm just here reporting as I see how it went down. So don't for a minute think that this is all my own work. Okay, I gave a similar review in previous meetings for 1.8 and 1.9, and you may or may not remember these slides. I sort of, partly for fun, but it sort of led to some interesting discussions. I invented some fairly arbitrary statistics to try and see how different versions have differed. And I looked at some measure of the amount of what we now have as pull requests between versions. And then I looked at the number of words and how the document was growing. And there was no sort of real great insight, but it was quite good. But I couldn't think of anything suitably arbitrary and new for this time. So I just sort of did the same values, and only for the last 3 versions, because these are the 3 that we've had on the now annual or approximately annual release cycle. That's our sort of promise, is to release at least once a year before this annual workshop. And we've only done it once a year. There hasn't been a need to do it more or a particular request. So these are the numbers for the last 3. You can see how many pull requests contributed to each version. Keep moving, this is terrible. I can see it here. What rate they came at in terms of obviously how many per month, and the number of net new words in the document. And well, I don't know, there's not much you can really say about this. The number that stands out is the 620, the size of the document. It hasn't really grown much. There would have been some deletions and some additions, but compared with last 1.9, a big change and previous years. But it's tempting to draw great significance into this and try and understand what's right or wrong about the world of CF, but that would be dangerous, I think, or wrong. And there are pull requests or open discussions that could, with a different parallel universe, they got finished and went into 1.10. And some of those have got a high word count, for example. So there's sort of sampling issues, and so I don't know. There's almost not much to say here, but there is probably a good reason, or it's probably worth keeping an eye on these things over the next decade. It might be interesting if the word count only goes up by 100 all versions. Does that mean we've finished? The CF done? But basically, yeah, that was nothing to see here, I think, fortunately or unfortunately. But there isn't a perfect metric to measure how CF is evolving, clearly. And it's certainly not these measures. These measures are incredibly non-robust and flaky, but quite fun to sort of calculate. Oh, well, I should say they're easy to calculate, which is why they were calculated, rather. Okay, so 7 pull requests went into 1.10, a relatively small number, and these are they. So we had 2 enhancements and 5 defect corrections. And because there are only 7, I thought I'd have time to have a look at a bit of detail as to exactly what these changes are, which I didn't do in previous reviews because there were too many. And I figured that's probably a good idea, because a lot of these things are only seen by a subset of people. Not everyone is paying huge amounts of attention to everything, because it's just not possible. So we'll all get to see exactly what went in. Oh, and these are the pull request links. So if you have the presentation, you can easily link through and see what they are. So the first one, it's not a sort of CF metadata content. It's just the reformatting of the history of the document. So this is what it used to look like until 1.10, was released a couple of weeks ago. So we had just a plain list in chronological order of all the changes, and the dates are the the dates at which the change was accepted, not the date at which it ended up in a document. So things are usually accepted sometime before a release date. And that, so you didn't really know which changes went into which version, looking back and so forth. But now it's organized much more like the changelog of a software library. So all of the changes are grouped into a version, the heading, and the versions are given in reverse chronological order. So I've only shown the 1.10, below that it will say 1.9, and so on. So yeah, useful, I guess, if you need to look at the revision history. So that's one thing. Oh, I should say, I've decided not to mention names generally in this about who was involved in stuff, partly because there's a lot of people, and in any one item, there's somebody who originally proposed it, then there's lots of people who discussed it, maybe someone else did some of the implementation. It's just, there's just too many to mention. But if you are interested, obviously the history is there in the issue and the pull request. So it's all open. Oh, and also, I didn't know 100% who everyone is because of GitHub handles. Obviously, I didn't want to be saying, and this was at 762, or which seems a little bit impersonal. Okay, the other enhancement again was a sort of non-CF metadata-y one. It's single sourcing the CF version number in the document. So this means, so in the CF conventions document, there's a number of places where it mentions the current version. Like for the global conventions attribute, you should put in CF 1.10. And these have now been replaced effectively with an environment variable. And so that its value can be set once in this new version control ASCII doc file. You can see at the top it's already set to 1.11. And now when you build the document, either manually or using the new GitHub automation actions, which are also part of this enhancement, it goes through and replaces obviously the environment variable with the version name. And so it can never be wrong again unless you get it wrong in the control file. But it had been wrong in the past, so this is useful. And I found it very useful when I was putting together the documents for 1.10 that are up on the website. It was great not to have to worry about yet another thing that I've forgotten to do. So those are the two enhancements. That's all that went in. So now we can look at the things that we call defects. And the first four, so there were 5 in all, I don't know, relatively small or straightforward. So the first one was about just clarifying that when you have a discrete sampling geometry feature type, the extra spatiotemporal coordinates that you can have that are not that are optional can also include an extra time axis coordinate as well as a spatial one. So you can see in the new text gives an example of a vertical coordinate and a temporal one. So just a minor clarification. I mean, this is only a snippet of the text. The new text is in red, and but the context was it was slightly ambiguous when you looked at it in a certain light. That's fixed. The next one, simply deleting the global conventions attribute from, it was 2 of the examples. There were 73 CDL examples in the document, and only 2 of them had mentioned the conventions attribute, which we would normally find in our data sets. And I think this came about, I didn't check, as a result of the single sourcing of the version number. It might have been a technical issue to do with implementing that it was handy not to have it in the examples. But in any case, it was inconsistent. So removing 2 of them, so now none of the examples have that in. That's it. A pretty minor change. The next one, yeah, so the original text, which dated right back to version 1, haven't been changed since, I think, that introduced a standard name was worded in such a way that it implied that the standard name was a hypothetical concept and that you could use if it existed. I'm probably over-egging it slightly, but that was the sort of, you could read it like that. So this new text is just designed to be slightly clearer that standard names do exist. They are real. We have them, and also offered a bit of extra guidance on their use in the file, that you can have multiple standard names in the same data set, and that they are sort of qualified by coordinates and cell methods and stuff, just to tidy that up. And this last one on this page, this is my absolute favorite. This is the missing semicolon on the coordinates attributes in this example, and it's fixed, and this matters obviously to we understand this. I think, don't need to explain myself. To anyone who's cut and paste CDL to try to use it, this is so those are great. We've tidied up some things, made some things which weren't really wrong but are now clearer than they were. Okay, now the last one. This is quite a bit more substantial in a number of ways. So this is correcting mistakes that crept into the description of lossy compression by coordinate subsampling, which is a big change. This is what accounted for most of the 22,000 words that were new in 1.9. There's a whole new part of chapter 8 and a whole new appendix that describes this this compression, and so that went in at 1.9, but then lots of mistakes were found. In fact, over 30 different parts of paragraphs, if you like, of text were found to have some sort of issue with them. It sounds like a lot, but as I say, this had about 16,000 new words of text. So as a percentage, we're probably coming in, better than par. So I haven't put all of them here, but there were a few which I thought were maybe sort of noteworthy. So the first one is a rogue parenthesis, which is probably a bit hard to see. It's that one after the GSQR variable. So that's gone. So that sort of garbled that equation. The next one in the list. So this is interesting. When I was picking these out to put in this slide, I couldn't work out why this was a defect at all, because if we look at these bits of text, if IB minus IA, these are two integers, is even, then IB minus IA plus 1 is odd. So it seems like a slightly pedantic change, just to change that. But the problem is that the interpolation subarea, whose size is being described by this integer, its size is elsewhere defined as IB minus IA plus 1. So the first text, the original text in black, we have the interpolation subarea has size IB minus IA plus 1, yet we're being instructed to do something if IB minus IA is even. Does it mean that number or the size of the interpolation area? Just a bit of a mess. So that one was quite subtle. And the last one, this is simply a case of the formulae for latitudes and longitudes. They're in the wrong order. They were switched. The two arctangent, argument arctangent things are just the wrong way around. Now, the first of these, the extra parenthesis, I call a sort of fairly benign error, insofar as if you were implementing using this, you'd come across that and it wouldn't work. You've got the one bracket too many, and you'd realize this. You wouldn't know what to do. You wouldn't know if there's it needed to be deleted, or if it had an opening bracket somewhere that was missing, but at least you'd know something was wrong. So you couldn't proceed blindly. But the second two, I think, are much more dangerous in some sense, is that you could you could implement what was written in 1.9 and not encounter an error when you come to push real data through it, potentially. You might, depends on the magnitudes of the various numbers involved. And then you could end up with some results, some uncompressed coordinates, which look plausible but are wrong. So this is sort of the most dangerous defect. Which have been fixed. So this got me thinking, and I think this was talked about a little bit when these defects were uncovered. Now, going back a bit of history, so between 1.6 and 1.7, it was there was a while up until 1.7, there was a rule in the CF conventions that said all changes to the document are provisional until they've been proven by 2 software implementations. And this was obviously a sort of a check and a balance. And this rule was dropped in 2015 after a very considered and careful discussion on the email list. And the basic reasons were that the text it produced with all these provisional changes to record was hard to read. It was never actually enforced, and nothing had ever been found to be wrong in the previous 15-year history of CF, basically. Things have been clarified and so forth, but they weren't wrong. They could just be maybe presented a bit better. But and this bit of text here, apart from the italics, is exactly how it used to look in the conventions documents, the original 1.6 document and before. I say original 1.6 because that was recreated in the new ASCII doc format, so you won't see this in 1.6, but it will be in 1.5 and before. So you have this text, and the yellow highlighted text with the strike through is the old text, and the purple highlighted text is what replaces it. And some parts of the conventions had quite a lot of this, so it's not very nice to read. And if you're interested in all the arguments for and against dropping this rule, there's a link here to the discussion. This sort of lands you in somewhere in the middle. There was sort of a summary of it, so you can work your way forward and backwards. And it's a good point to mention that this link is to a new copy of the pre-GitHub era archive of CF discussions, all discussions on the email discussions and track ticket enhancements and stuff, which is also only just gone up in the last 2 or 3 weeks. And this is a copy. This is a copy of the archive that's always has and still is hosted by UCAR. So in something, think of what you like as a backup. But this history is available, and it's linked from the conventions tab in the website, also the discussions tab, and you can access all of our old arguments. So, so the point I'm trying to make here, I didn't just bring this up to fill up another 5 minutes, is that it is a fact that these defects in the lossy compression by coordinate subsampling were discovered because 2 software libraries implemented it. And when you come to implement this brackets, what do we do here? And it was discussed and fixed. And so without that, there's all these errors would still be there until somebody came around to implementing it. And if those only came up in a few years' time when the people have forgotten how it all worked and stuff, it could be pretty bad. And it's also worth noting that the only other time we've had an actual error, definitive error in CF, was something that was fixed. It'd actually been in there from the beginning, but it was fixed in the previous version. And this was the formula that defined how to calculate depth coordinates from parametric ocean sigma over z coordinates. And this also, as it happens, was uncovered following a discussion that arose from an implementation that was aiming to calculate this. So I'm seeing a slight pattern here, possibly. Okay, so you all thought I was going to say we should bring the rule back, maybe, but I don't. I absolutely don't. I read all the arguments before and for doing this, but I think maybe a sort of rule, a light version. There's maybe a place for it, and not for everything. So I put a significantly complicated new features clearly could benefit from this and save us a lot of grief further down the line. So, and say I've not discussed this with anyone, these are just some ideas I'm putting out, but how I might imagine it is that this would be something that would happen during the discussion phase before something is accepted. So it's not something that's going in and then having to be checked after the event. And I think it would be very much, it's a discretion issue about whether or not it's done. The moderator maybe is the obvious person to think about that. But how do they, how do they decide? So a text change that clarifies the role of standard names. I don't think we need a software implementation for that. It's not possible. But clearly, things with equations, which is not most of what we're doing typically. Well, we've had 2 examples where it would have been good. So, and I'm not imagining, if you've got a group of people discussing something, they decide it'd be nice if we actually tried this out from the text as written. Doesn't, I'm not saying publish it or share it or document it and make it nice. It'd be just, if it's there in the discussion, we did these checks and it all looks good. That's a lot more than we're doing already for complicated, whatever that means, things. So, and I should say I think I have a slightly vested interest in this. So myself and Sadie Bartholomew, we develop and support the CFDM software package, which is a reference implementation of the CF data model. And we are duty bound to implement all new features as they come, not only so they can be represented in memory, but so we can read and write them from files, read them from and write them to files. So it's nice that we don't have to discover this ourselves and then say, well, hell, this doesn't work, and then try and find the people who know why it might not work, and we're into that. So I don't know. From a personal perspective, I would welcome a bit more checking for sufficiently complicated things. But there you go. That's just an idea. We can chat about it over coffee or on GitHub. And maybe it's a guidance in the contributing document, nothing formal. Anyway, lossy compression by coordinate subsampling now is okay. So there's been 2 implementations. I say one was written in Julia by Anders Sorensen, who led the development of that enhancement, and I wrote the other one for CFDM in Python. And they have, they have unit tests and everything. So I think we're happy now that this very complicated equation-heavy enhancement is okay. And they don't come around very often. How many equations are there in CF apart from formula terms? There's these compression ones, but are there any more? Maybe I haven't thought. So, well, something maybe to think about. Okay. Oh, yeah. So what you can't quite read, I didn't realize that was hidden. So this says what didn't quite make it into CF 1.10. So I alluded that some things that might have gone in could have changed my random statistics at the beginning. And just 2 I've picked out, which I, in my perception, might have gone in and are close or close-ish, these 2. So first one, incorporating UGrid into CF. So UGrid is a representation of unstructured grids. So that exists as its own sort of standard, and the aim is to sort of reference it from CF and accept that it is part of it rather than copying it in. But that's pretty much ready to go. we're just waiting for a conformance document to be published. It's been written, so I mean, that really could have gone in. That's for next year. And the other one is the clarification of temperature units, the dreaded 101. So this was long, it is long and complicated, even by CF standards. These 190 comments, 16 participants, this is pretty good for us. This still needs a bit of work, and say much of this has happened sort of off list, which is sometimes where these things have to go to make progress. But I am very confident that this will be going in for 1.11, and and sooner in the latest draft. So, so I thought it's worth mentioning those because, yeah, in the parallel universe, this talk is quite different. Okay, so the CF data model didn't change. So all these changes and defects we've seen, they don't change the logical structure of CF in any way. So that's easy. The UGrid, bringing in UGrid will change the data model, but I'm not allowed to talk about that for next year. You can read it in the issue if you're interested in advance. Okay, so to finish, I'll mention some things that the governance activities that have gone on in the last year. And the first is our pin there, which is maybe ironic, acknowledging contributions. So it's always been the case, and still is the case, that those who lead changes to the conventions are included in the author list of the main document. You can see them there on the right, and we currently have 27 main authors of the main document. And contributors to standard names are listed separately, and there's on the sort of standard names page on the website, there's a nice list of everyone who's contributed, which I presume Alison updates when the standard name table is updated. And we currently have 181 people over the years have worked on standard names. This is great. All these people are, we're getting our due acknowledgement. But there's now a new third collection, which is a collection of contributors who have made a significant contribution, even if they didn't lead a change, but have been considerably active in a discussion. And importantly, whether or not the change ended up being accepted or not. So the authors of the main document are people who've led changes that made it into the document. But quite often there've been long discussions, very interesting ones that for all sorts of good reasons have been parked or not proceeded at this time. But this is still clearly, contributing to the whole sort of CF community. So the initial list was compiled by going through the entire discussion record on whatever medium it happened, dating back to 2006. And a list of names was compiled as to who had made significant contributions, which is, of course, a judgment call, and they've already made some adjustments. And a retrospective look is quite difficult. But there is a new procedure in place that the moderator of the discussion, when it's closed for or finished for, however it was resolved, will note who the main players are, so that when this new list comes to get updated, which it will be annually is the plan, within line probably with conventions releases, it's easy to go through and find these people and just add them to the list rather than having to go and reread all the discussions and make an after the event judgment call. So I think this is a good addition. And here is the list. So it contains 78, I think it is, names. This includes the 27 main authors from the conventions document, but it doesn't necessarily include people from the standard names contribution. That's sort of considered a separate activity for this, but there's a large overlap, as you would expect. People are putting their fingers in many CF pies. And this is the text that preambles it on the page, which you can access through the Conventions tab. So that's good. And I should just say the institutions listed are the institutions these people were in at the time that they were contributing. And that's a static attribution. That's not going to be updated and follow you around, which might be good. I don't know. Okay, I think this is possibly the last slide. The other thing that the governance panel was active in, one of the things this year was looking at setting up a license for the use of CF and also assigning digital object identifiers, DOIs, to CF somehow, and how you and what granularity that is. And the governance panel looked at this and consulted with anyone who was interested, a few people who were quite keen on moving this forward. And they came up with some proposals, one for a license, a way forward on the license and the DOIs, which are given in these issues. And these were put up in, I think, the end of March this year. And there's been no further comment of any sort on them, which basically means everybody's happy with them, which is good. So this is a topic for Thursday morning. We've got in the agenda to go look at this, discuss it if it needs discussing, and then do it. So that's a plug for that. So I don't need to say anything else. But that will be a really good outcome of this meeting, amongst everything else, if we can get this. We started talking about this, I don't know how many years ago. At least, I remember 2018, certainly we talked about it in the CF meeting, probably before that. Okay, that's it. Again, thanks for everyone who gave their time and expertise to get us this far. Yeah, questions, Steve?
Going back to your kind of with the lossy compression stuff and the problems of not finding out until the software implementation was made, what a lot of obviously quite large projects do is, if they are making a spec, they also make a reference implementation of that spec. So it's not, and it doesn't prevent anyone else making implementations of it, but obviously it's a bigger ask, but obviously people like yourself are making the implementations pretty much immediately after the specs are run. So is it possible to combine the release of CF with a reference spec? So in that case, you've built this thing and say, here is our spec, here is our spec, here is an implementation of that spec, which goes through that step of making it happen.
So Sadie and I sort of do this for the CFDM library, and again, it's just one library, but we don't really have the resources to be so responsive. So so I don't know how else, unless I suddenly find a little bit more time in my life, and
I appreciate, or
somebody does, but it depends how. But the thing is, for CFDM, it's an all-encompassing library that tries to cover every corner case, and so sometimes implementing things can be quite lengthy, particularly when there's a lot of complicated and file encoding to deal with. Whereas a simpler sort of I don't know what the word is, sort of sandbox test that doesn't have to worry about any other CF machinery might be easier. But again, someone still has to stand up and say, I'm going to do it.
Oh yeah, I fully appreciate that, but that is an approach as to how projects do kind of get over this problem. And maybe you split it into, maybe it does get split into lots of tiny little reference, a reference implementation for each item, maybe, I don't know. But it's something to potentially think about, since that work is kind of happening anyway, just at a delayed mode. I don't know.
And of course, it would be nice if, even if people were making little, here's my little test of this, it seems okay. And I imagined you wouldn't even have wouldn't have to maybe necessarily publish it. I was thinking of not putting barriers in, but it would be obviously nice if these could be collated in a GitHub thing as code snippets.
Oh yeah, absolutely.
If people were happy with that.
Yeah. Or you know, I mean, we've done like the whole unit testing. We just check it out and run everything.
Yeah,
and you get a yes or a no.
that would be nice.
Just,
I think.
yeah, it's a lot of work.
It's the resource.
Yeah,
that's all it is. I think. Yeah.
Always.
Do you have any idea how many active contributors we currently have just yet? I mean, like same names to how big a team?
I don't know. I've looked through a lot of the 7 issues, for example, that went in, and I'm just trying to. I didn't count them, and so I'm thinking about all the work that's gone on for the website and say governance activities, and then there's the discussions about the conventions text themselves. Who wants to have a number? 30? Yeah, over the last year, more? Yeah. I don't want to.
Not bad.
Nobody's raising or lowering that. Do we have any further bids? Yeah, between 0 and 1,000.
We are at the Physics Institute, so that's a valid way to guess things.
Yeah.
There's one simple question about the document itself, is because it's becoming very lax at the moment. And I mean, with the discrete sampling geometries,
Yeah.
Flash, but if we are going to incorporate the UV, it's going to become larger and larger. And then I don't know if there is any discussion on this or how to split it or.
Yeah,
It's because it's difficult. Not difficult. Sorry. Sometimes it's been mentioned in something, some text, and another one. Sometimes.
Yeah. Not that I'm aware of. I mean, I guess to some extent the stuff that's coming in now is sort of maybe by definition this is the hard stuff. You know, we've at the beginning it was quite easy to represent rectangular regular grids with 1D coordinates, and that did for a lot of climate work. And now with unstructured grids and compression and it's maybe a case of all new things are going to be more complicated sort of by definition, because they would have been done already otherwise. I mean, this is wishy-washy argument, but yeah, it could only get.
Yeah, because I'm thinking there is core standard or something that's like the code of this year. Then there is also some additional, not additional, I don't want to say additional, but more things just.
Yeah, I suppose the original chapters, sort of 1 through 7, I mean, they've largely stayed roughly the same size all the years. All the new stuff's been sort of ring fenced in its own sort of horrible bit at the back of the documents that's about 200 pages long.
Yeah, that's the reason because yes.
But the whole document is 200. The PDF version is 228 pages now. So I mean, if you just said, well, I'm going to sit down and read this, and you didn't know that, okay, I can ignore that bit of lossy compression. That's sort of 30 pages of really messy stuff. It's quite a daunting. Yeah, some guidance. Yeah, you can stop at chapter 7 if.
More or less, yes.
And you'll have captured sort of Well, it depends on what if all you use are sort of discrete sampling geometries, you can skip chapters 1 to 7 and go into chapter 9. But yeah, so I don't know. I guess when it gets to 1,000 pages, we'll have this conversation again.
We call it the encyclopedia.
Okay. Oh,
sorry. Yeah, just around this issue of obviously again discovering these issues that you've got. I mean, at what point were they discovered? And there doesn't appear to be a mechanism to kind of obviously these things were discovered in 1.9 and updated in 1.10. Doesn't seem that there's a mechanism kind of patching the release to say, hey, we found an issue in 1.9, we need to fix it.
Yeah, well,
Because I mean, these are fairly fundamental problems that stop people doing stuff, you know.
they are. So I think these were discovered. So 1.9 was released in September last year. These were discovered just a month, a few weeks afterwards.
Yeah.
And then they were fixed another few weeks after that. So pretty soon afterwards. And we did have a discussion about whether or not this warranted a 1.10 or 1.9.1. I'm not. This is slightly uncharted territory, and I think we did, amongst us who working on it, and Daniel might correct my memory, I think we decided, because it was such a niche thing, no one else will have looked at this yet. We'll just fix it, and it's in the latest then already.
Sure, yeah.
But it's not in the frozen. Anyone who goes back and says, I'm going to now work on 1.9, they're still in trouble.
Yeah.
But one thing I realized just yesterday actually was, for the correction in the formula terms, we put in some text that basically said this is now right and previous versions were wrong, you know, watch out. But we didn't do that for this.
Should have done.
We should have done. Yeah,
We could still accept that new text as an enhancement.
Yeah.
for 1.11.
Yeah, exactly.
So we should have done that.
Yeah.
So at least people are.
Yeah, I mean, I just wonder if having kind of patch releases 1.9.1 would make it clear that there are things that are happening.
I think
it's a tough
yes.
one, and
I
obviously
mean, maybe
all
with
this stuff
hindsight,
before.
we should have done. But I think that needs just a little bit more discussion on what we think, how we want to manage things, and now that it's something like that has happened. You should have, rather than having this sort of notion, well, we might do a new release. But I think before we thought, if somebody has a new feature that's accepted that they really need for maybe an operational product, and they can't wait till the end of the year, that's a good reason to do like an extra release in here. But I'm not sure if we discussed what that would be called. Should we stick to the
I mean,
big number, the 10, 11, 12 for an annual thing, or not?
Yeah,
from
that's-
1.11, 1.12 for next year.
that's a slightly different discussion, absolutely. But
But we should have that. I think now.
absolutely.
We have that.
Could I make a comment, David?
Please do, John.
What the protocol is for speaking up, but I'm just doing it.
Yeah.
You probably mentioned that the other thing, the ocean sigma over Z formula terms, of course, that was an error right back to all the earlier versions. I'm not sure it would have been a big overhead to produce 0.1 subversions of all the existing versions.
Oh no, I don't think you would ever do that.
Okay, right.
Well, I mean, I come from a software engineering background, which is how I'm thinking about this. But you make the release at the point you fix it. And you can put, you know, when you make that release, you can say this affected everything else.
Right. So you wouldn't, as we've just discussed, we can put a notice in the current version saying all the previous ones had this error, which is now corrected. We can put that, maybe we should put that notice on the website as well, since you wouldn't see it in the text of the old versions if you happen to be looking at them.
No. and people will be looking at them if they're, you know, your project's still working at 1.7 because you've frozen that for good reason.
It may be worth, I mean, I'm not familiar enough with this, but it may be worth, if there's stuff attached to those individual versions, if there's like known bugs in this release, just so you can write that kind of stuff.
That'd be a useful web page.
I think we've had discussions about having a page listing changes or bugs. But we never.
It should probably be attached to the document as well. Because, as you'll find out from me later, no one ever reads the web page behind any of this stuff, but it needs, you know. But yes, wherever it goes, it would be useful to have.
Okay. I think we'll carry this on later, but we should move on. Yes.
Yeah, we need to move the
Hi everyone, so I'm Sadie Bartholomew. I'm from the National Centre for Atmospheric Science and the University of Reading, so same as David actually. So I'm giving this presentation on behalf of the CF Training Committee, which is a number of us, and you'll see names mentioned throughout the presentation. I'll not name everyone, although I will give a shout out to Alison Pamment, who was chair of the committee. So I'm giving this talk on behalf of everyone, really. And I will give the context in a second. Yes, so the background. So I'm using this this acronym, this British acronym TLDR, which means too long, don't read. Basically, you don't need to read all this slide. But the main thing is that we held some CF training last week. So specifically, this was on Thursday, 3 hours. We held it in these times, catered for, I think, mainly the American and European time zones. Because obviously CF has an international audience. There were, I put 50 plus registered attendees. I was hoping to replace that with a more precise figure. I don't know if anyone who was in attendance, co-hosting, knows anything more.
Actually, about half of the people who registered that.
So I thought I'd noticed that. I was
25. I think the thing was online, register an interest, they're not always
there. Okay, so maybe that figure is a bit more grand than the actual attendance we got. But we did get, say, 25 roughly, which is good. So this session was aimed primarily at people who are new to CF or fairly new. We did specify that on the sign-up sheet and when we advertised it. And the intention is to continue training as a series to also target more advanced users. And yeah, well, this is going to go to discussion at the end. I'll mention that on the next slide. But we started with something in the hope that we could kind of initiate a training series. But really, we'd like the community to tell us what they want to know. But it helps to begin with something, and that's what we've done, I guess. So the context is that there was no kind of formal or recognized and I guess consolidated in the sense of integrated or working together as a series training or instruction into CF or relating closely enough to CF in existence. There may have been some pages that I think we've seen, but they were, I guess, unaffiliated and not integrated. So we were hoping for something like this. I put a figure here that by 2021, we plan to begin organising some training. That was completely off the top of my head, based on when David has mentioned that we'd like to do this. So I don't know if anyone, again, knows more on when training was kind of conceived.
decision really last year's meeting.
Oh, okay. Oh, brilliant. So yes, that was an outcome of the previous workshop. That we realised that would be a good thing, and we have made progress on it, which is great. So the overview of this session. So I should say I'm going to talk for a bit. I put 10 minutes and 5 minutes here, but actually it'd be maybe 15 minutes for this first point where I'm setting in the first training, and then just maybe 1 minute because I'm going to pose some questions to you as prompts, and then go into some discussion. So I'm afraid there is some audience participation, but it's up to you. However, much you want to say or however much you might think about it, but thought providing some questions might hopefully inspire people to think about things that might help them provide feedback or make comments. Because I realise I'm putting you on the spot a bit, and 15 minutes isn't very long. So, but I think we arranged this so we've got the coffee break straight after, which means that if people want to continue discussions, they can do that in the coffee break. Yeah, so I think. Because, like I say, it was last Thursday the training was held, so that's really not long ago. So it's still fairly fresh in the minds of the people that were there, either hosting or co-hosting or attending. So yeah, it's just a good time to think about that. Obviously, I think we deliberately put it close to the CF workshop, I believe, because that sort of makes sense. Although it was held virtually. I think I'll put that on another slide, but. Well, I guess it was implied by the fact we're in a certain time zone. Maybe not, but anyway. So just to summarize the first training, not sure. I just check, did we begin the talk at 1:45? Okay, just so I'm trying to keep it down. So as I mentioned before, it was aimed at beginners or those fairly new to CF, although I think we did put on the website when we were advertising the training that it might be useful to those more experienced as well. And I feel like I'm trying to say I am experienced in CF. I feel like I definitely should be. and I found it very useful. So I'll just recap various things. And it is going to be, we are going to include more advanced users of CF and people who aren't users, but we hope could become users of CF in our scope. I think we wanted to begin with aiming it at people who are fairly new, because I think that's a sensible starting place. Then you can build up to more advanced concepts, say, or more specific concepts. So the training here was designed to be self-contained and sustainable. So I mean that in the sense of like 3-hour-long sessions, and wanted things to cover a whole range of aspects without missing anything important. And sustainable in the sense that we've actually got some recordings that were made separately because we realized that live sessions can be a bit disruptive. There could be various things popping up and questions, so on. So we do have some recordings that were made in advance that will be put up on the YouTube channel here. And I'll put this link at the end. Unfortunately, it's just a horrible hash at the end, but that's apparently the link you get to YouTube. We have a new dedicated YouTube channel. It was created for the training, but I think possibly we could put non-training materials, other things related to CF in there. But either way, sort of home CF conventions on YouTube. And yeah, I'm quite aware of this, or soon to be uploaded, or soon to be, because I haven't actually uploaded my component. So I think this will be done shortly, and I can only apologise because maybe I'm holding things up there. Oh yes, so in terms of attendees, actually we've discussed this, I guess, and I was kind of correct here in that we had plenty registered, about half of that did attend, which is fine, because Alison says it's quite natural that some people can't make it for whatever reason or don't want to, and since it wasn't we didn't charge for this training, that's probably quite natural that people might drop out. So the agenda, so this is what we discussed, and I'm not going to go through the entire agenda just for time, but I will put it up there if you want to read things out. One thing I will point out is that I think we covered all the questions that you might want to ask about CF. So try to remember all the question words. So what, obviously, with the 2 introductions at the start, and that probably touches on who and when, maybe. Obviously, we've got why here, why use CF, which is a really important one. And some hows. So, for example, I covered how to contribute to CF. And I think some of these talks cover various question words, but I think those are all the question words I think of. So yeah, it was a very varied agenda, and it was great that there were lots of different people speaking up. It wasn't just one person giving huge sections. Although I think the next time we'd absolutely welcome other people to join in, because it's nice to not just have the same faces. But yeah, we got a good mix, I think. Okay, so now for some statistics, and I guess I'd like to apologise because usually I'd like to do some nice visuals of anything related to numbers. But so we obviously held this Thursday last week. I was actually at another conference last week, including on the Friday, and then Sunday, Monday, I was kind of being a tourist in Barcelona, so it's not really an excuse, but I just copied out the questions and the responses, added them in some percentages. And on the next slide, I didn't have time to even add the percentages because I was typing away during David's talk. So I might try some mental maths, but I might not for safety. So I guess actually we're all right for time. Yeah. So the questions that were asked, and Alison worked out how to do some polls on Zoom, which was a really good feature, actually. I'd recommend. I don't know what you use, but I guess we could talk about that another time, maybe. Or oh, it's built in Zoom. Oh, very nice. Yeah. Oh, well, Zoom's impressed me there. Okay, so yes, we asked some questions. So I think for all of these on this, yes, for all of these on this slide, somehow 20 people responded. Although I think there were separate questions, so, or maybe they were asked at once, because on the next slide there were a different amount of people responding. So I put that in the kind of, I guess, the first yeah, and then hopefully that's self-explanatory. But if you're not sure what I'm referring to in some things, do let me know. For the first response, in some cases, I've put the number of participants, respondents, as you say. So yeah, I guess I'll just read these questions out quickly. Have you ever used CF metadata when reading or writing data? And 85% said yes. And interestingly, our next question, have you ever used CF standard names for variables? So 85% said yes for this as well. Obviously, the other option being no. And only those two options being given, so no kind of, I don't know, type answers there. Do you or will you use CF mainly for, and then various responses, various possible answers were given, and I'll note that respondents could have chose multiple ones, not just one at a time. Maybe I'll not read all those out, but I think interestingly, more people than not said they used CF mainly for reading and analysing data and writing data, but not so many for searching data. So that's an interesting point there. So how would you rate your knowledge of the CF conventions? And most people said I know a little, as opposed to I'm a complete beginner or I know a lot. So I think that they were quite interesting. Obviously, the sample size wasn't huge, but and we said we'd aim the training, advertised it as such, as being for beginners. So that obviously influences the last question. And finally, so this was some feedback we gathered at the end, whereas the previous stats were at the start. And as I mentioned before, there's no percentages on this, so I guess just use your technical scientific knowledge to calculate if you wish. But I think these were very promising, actually. Did you find this training session useful? And no one said not at all useful, which is great. And most people said very useful. How should the CF training be organised? Again, this was nice because the majority of respondents said a longer session of 2 to 3 hours on several topics, which is what we've done. So that was nice. Although obviously some people said perhaps other things, which I guess if everyone had said one of those, it'd be like, great, we'll go ahead with that. But obviously one choice isn't perfect for everyone. And how do we cater for that, I guess, is a question that I'll throw out, because I'm going to throw out a lot of questions in the next slide. How often should we offer the CF training? So once per year, what was the most common response? It looks like more often than twice is not what people want. Again, the sample size isn't great. There's a final question, although I think, yeah, I was copying in some stats from a spreadsheet during David's talk. I apologize to you, David. Just based on the lack of time I've had between the training and now work time, I should say. So yes, only 2 people responded and I've lost the stats. So that was a question we asked and I have no idea what it said. So right, so I said the last 15 minutes would be good to, I guess, discuss the training. I realize that's super open-ended and probably just will lead us nowhere. So what I was thinking is I put some questions up which may prompt discussion, and yes, well, I put them all on one slide so we can read them here, but obviously it's probably a bit overwhelming as it is. I was wondering the best way to do this, maybe we could break up into small groups to discuss things. I don't know if there's, yeah, whatever I say, if there's going to be huge enthusiasm based on the fact it's nearly coffee time, but I guess the main thing to say is that there's a few questions here that are the direct questions, really the questions that we are looking to answer, which is quite obvious ones. What would you like to see covered by training, and how can we best deliver training, particularly given that we've got an international audience. So for example, we had to do the first training session at a time zone which would suit, I think, American and European time zones, which obviously is a bit exclusionary to say Asian time zones, perhaps. But you know, it's hard to find a time that will cater for everyone. So there's a sort of question itself, when. And then there's some indirect questions which I thought might help us think about, I guess, the larger picture for CF in general, which may be covered by other people during this workshop, or just as obviously a background question. But I think in particular, if there's anything that you think, but what knowledge is missing to you? Maybe that's not the best wording. Actually, I was trying to put it on one line. What would you have liked to have known about CF at a certain point? So say right now, is there anything that you think, oh, I don't know about that? Or thinking back to when you first started working with CF, which I don't think for anyone here, but if I take this in an arbitrary way, could be you could be someone, actually, let me take the second one, when you had a little bit of CF experience, that could be some people here, although possibly everyone has more experience than that. But I guess my point is, all three of these questions some of these questions might be the same question to you. Yeah, I guess that's the thing to think about. Because if there's some knowledge that you don't have, or something you'd like to know, that's really important, I think, because that can help us guide us as to what we might want to talk about. And yeah, the big, I guess, barriers as well, because I think if there's something that's stopping someone from, say, using data in a CF compliant way, using the metadata in the way we'd like, that's obviously important as well. And yeah, the big picture of where would you like to see CF in the future, including in the very long term future, just thinking to a world where we might be all underwater or something. Yeah, so they're my questions. Actually, quickly, I'll just say on these slides, although I'll put the prompts for discussion back up. I've just got a few links.
I had a question.
Yes, although I'm not sure, I don't have a pen. Well,
No,
probably can't go on there.
I'll just say, but most, if not all, of the people who provided the training are at this meeting. So,
Yes.
but what is, how much resource can people who might be delivering it think is they can do? You know, two
That's a good
training,
one,
if you
yes.
want to do 2 a year, who's going to actually do that? That's something we should not promise unrealistic things that maybe, you know, if we're all doing the day jobs.
Sure,
And you can
realistically,
do it in
yes.
different time zones as well.
Mhm.
That in the end, you just realise it's going to be too hard to do it. Asian time. Just the same few people doing.
Sure. So I think, yes, maybe we summarize that maybe all of these questions kind of add realistically. That makes sense in context. And yeah, I've got a few hands. I should just say maybe I should have had a session where we, or like 2 minutes where we add questions to the prompts before we go ahead. But yes, questions.
I was just going to follow up on David's
Oh, sure.
comment. I think it's really, really useful that some training is coming around and that we're actioning on this. It's great because a lot of people have been asking for it for a couple of years now. So it's really great that you've got together. And if you want my involvement going forward, I know I didn't volunteer at first, but happy to be involved going forward. But in terms of the resources thing, I think we've had a sort of introductory training period for people who, you know, just need that basic knowledge, and then going forward, people probably want more advanced training and things. But I think in terms of resources, having that recorded training sessions and that online material is going to be really useful going forward, because I think people who sometimes have a little bit of knowledge about CF, but they want to know that more detailed or specific knowledge that is relevant to them. They search online, they look for in the document. And it's those people who are looking for something at the time when they're doing their work is when they're looking for guidance, which doesn't sometimes exist. So it's that, perhaps that recorded, as you say, like you've got the YouTube channel will be really useful if there's recorded material on there, and sort of cheat sheets and PDFs that exist would be really useful, because it's great to go to a training event at, you know, one summer in 2022, but
yeah, at the time.
it's that kind of a year later, oh, I need that information as I'm doing that bit of work. And so those bits of recorded information and having it down on paper or videos and things like that, it can be really, really useful as well. And then that sort of frees up people's time, that they don't have to be doing it all, you know, several times a year or things like that.
Yeah, that's a great point. I think you're absolutely right that when we put out these videos, hopefully in the long run, it's going to save us this time that would otherwise be trying to answer questions. Or so hopefully it'll be worthwhile in that sense as well, on a resourcing scale. But just generally, yes, I think it's a really key point that people. Well, it's nice to do one session at the same time, but usually it's as and when you have a problem or you want to know something, look it up. So yes, just reminded me that I really need to get my own the video that I did for my own little part uploaded. I think there's about 4 on the YouTube channel at the moment. So
So about half of the number of talks we had in the session.
yes.
I've been watching.
Okay. Hopefully I can put my video up for you.
It's only been a few days, so we'll let you on.
Just mention there's a training area on the website where you can access the YouTube channel.
Oh yeah, sorry. So I
Mm.
think I put some links at the end, and I'm going to go back to the prompts, obviously, 'cause, I guess what we hopefully want to talk about. We might need to go very into the coffee break. Yes, so there's one. Well, it's all on the website now. The training page which links into training page, which is self-linked into the training workshop that we held last week, and then the YouTube channel that's there. And I guess I put, obviously we're going to discuss this at the workshop and particularly now, but if you have comments after that, feel free to email me. I've just put my email because it's easiest, but obviously I'll forward anything to people who are invested in the training. And yes, as pointed out, I guess if you want to help with training, I'm sure we'd welcome you. And is Alison, you maybe the best person to get in touch with about that?
Can do. I think what I'd most like to know is what training doing for what. Because we just put things out to the hat.
It's the people online that it would be good to hear from. Comments.
The reason we asked that question, what would you like training in? But we were getting quite close to the end of the session, so we didn't leave the question of their creation. People can't always think of anything to start. But maybe we need a suggestions box or something. People can.
One of the issues on GitHub.
Yeah.
maybe.
Well, it could be, yeah, a really good idea, because actually it's a good point that I'm asking you all these questions, but really it's the community that we need to ask these questions to. So if anyone has any ideas about, yes, the best way to do that, to get people to provide feedback, which is sometimes really difficult. I think that's why we had some feedback in the session itself, because if we'd have sent an email saying, can you fill out this poll, in my experience, that doesn't get that much response. Brilliant. Okay. Yes, where to start with these prompts for discussion? I don't know, does anyone actually, did you have a question? If it's kind of invalid now, just feel free to redact it or, but.
With the disclaimer that I don't want to delay the coffee break.
Well, that's fine, we can continue into coffee, I think it's 5 minutes left.
That you can treat this now.
We can discuss over coffee.
I'd like to read the phone book. The first point up there is related to my question. I just didn't understand if we were going to break into breakout groups now here, or if this is what can talk about during the coffee break. If we're going to break into breakout groups and report back, then I'll ask my question then.
I think when we have more time, I would have said we'll break up into groups, but maybe I could even just leave these as questions so that you can deliberate whenever you want, really. I guess definitely over coffee is a good time now. I just think we've only got 5 minutes left. It might be a bit silly to try and break people up at this point.
Maybe we did discuss it, and however, but write things into the Google Doc that we discover, and then everyone can
yes,
see
that'd be
them
brilliant.
on the Zoom as well. So after coffee, any ideas we've had to go in there.
That would be great. Yes, I should add.
And then
Anyone
people
watching on
the
Zoom
can
is
put
very
stuff
welcome.
into
Yes.
Google Doc, the chat doc thing.
Yes. So when I say coffee break, I mean just general break, and obviously people online are
I
very
think we
welcome
should hear
to.
Charlie's question now, and then we can talk about.
Then we can
as
think
drinking
about it.
coffee.
No, it's pretty simple. Do any of the organizers of the training session, thank you everyone for organizing and delivering these training sessions. Did you get feedback from the people who took the training session that surprised you, such as, wow, I really enjoyed this example or this part of the training? I'd like to hear about that and what your thoughts are on why that was particularly welcomed by the newer users. What is it that was unclear before and that the training really got people over the hump with? I didn't hear any feedback.
Sure. So I mean, obviously, I provided some generic questions that we asked to people, but I think in the chat, the Zoom chat, we did get some kind of ad hoc comments. I can only really remember one relating to my session because I was kind of try to follow along with other people's sessions, and maybe people can, well, I'll give people a chance to speak in case they saw any people that were either co-hosting or attending. So for my session, which was on my part, which is about how to contribute to CF. One nice thing I saw was someone saying, essentially, thanks for assuming that we're not not used to using GitHub, or that we're not familiar with GitHub, some sort of wording like that, because I realized that GitHub some people may be slightly intimidated by it, or they may not have an account and think, oh, set up this account, and it may be a bit of a barrier. So I tried to assume not much knowledge of GitHub, and I'm glad that someone found that useful.
Yes. There was some positive comment also about the presentation about profiles for gliders using the discrete sample geometries, for example. There was some positive, because also there was some examples from, I don't remember the name, external. They provide also a document, 2 documents, sorry, for as templates for filling metadata also in data.
So like a real world example.
Was on the audience sharing that. Okay, yeah, sorry. So is the positive comment on that. There was some positive on Git about the discrete sampling units, for example.
Yeah, there was an issue in the last few days that came in about examples, data sets. Was that the same person or? Sorry? Yeah. Is that what?
I think you're asking for examples. I posted the issue.
Oh, okay, yeah.
I didn't comment this in the training.
Okay.
Did you post the training? Yes.
Oh, yeah, it's great to hear that. Obviously, I'm aware of a few people who I know were in attendance rather than kind of on the hosting side. Hope people found it useful, and I guess yeah, if you did attend the training that we just held, I think your feedback is, I wouldn't want to say especially welcome, but obviously it's you have the context to make it really useful. Sure.
I think, the challenges you kind of pointed out is how to engage the community to figure out what training they want. And I'll say, I think it's good that you don't focus on, that you don't expect people to know Git, because I think a lot of people that want to use it may not be part of that. I mean, something like CF office hours every month, or something like that, where people could come in and ask a quick question to someone that knew the answer, or could provide topics that they wanted to learn more about. Questions are how to engage the community and how to resource it, who's going to do it. That's the problem. That's a real question.
No, I like that idea, that kind of office hours. I think one of the difficulties is it's certain people in the community have certain knowledge relating to CF, and it's how to almost match the person's question with who might know, because I don't have certain expertise, say in certain, well, various types of the science. I might need someone who, if someone asks a question, I couldn't answer it, but whoever would. So it's the matching of the relevant person, which is, I guess, is a related problem. But yeah, office hours is a good kind of idea that we can.
Engaging the science community is really would be good, and they don't necessarily know Git and all the techie stuff, right? How to engage with them, because we need them for things like standard names. We have to have domain experts to help us define these names.
True, yeah, there's domain experts, and there's people more on the tech side, there's people somewhere in between, and yes, how to communicate in the right way and get the right people talking is the planned problem. Real, so I don't want to hold up coffee. I don't know if there's any.
Okay, well, great. Welcome back from coffee. I hope you're all fully caffeinated. I talked a little bit last year about some of the work we're doing within the WMO to start using NetCDF as a data exchange format. So I'll give a little bit of update about the activities that we've been doing in the past year. So some background for those that may not be familiar, and for those that are, apologies for the replication, but the WMO is the World Meteorological Organization. They have something called the WMO Information System, which is the WIS, which contains a data exchange mechanism called the Global Telecommunications System, GTS. So lots of acronyms here. The GTS is basically how the data is exchanged in near real time and gets into the operational forecasts things like, ECMWF and NCEF, grab the data off the GTS. These can be atmospheric observations, ocean observations, in situ observations, and use those in their processes. The exchange format of choice is BUFR, so that's one thing about the GTS that makes it difficult. There's lots of other things about the GTS that make it difficult. It's difficult to actually connect to the GTS. You can't just go and get data off the GTS. You kind of have to go through a National Weather Service or a national center somehow. So to confront that, the WMO is kind of developing what they're calling the evolution of the WIS, or the WIS 2.0, which is going to incorporate existing services, technologies, the internet, for example, and recognize that there's a distributed nature of data providers. It's not all in one data, it's not all in one place. There's services all over the world that they need to tap into. And one way to do that is, you got to support more data formats and move away from downloads and move towards data services. So it's still a long ways away, but it's moving forward, and I'm actually quite happy to see that happening. It's really great. So I should have mentioned on the introductory slide that there's a test team on CDF that was developed and created through the WMO. It's part of the expert team on data services and data. And the idea was to develop these regulatory materials to define CFNet CDF profiles. So the WMO is very bureaucratic, and they have to be, because they have a whole community they have to support, and everyone has to be on the same page. And so in order to support NetCDF, excuse me, we have to define these data profiles that will go into the WMO data manual. And so it's important to work with the CF community here to make sure that we can do that. And so you'll see on the right side there the several of the people that are on the testing for NetCDF, the team there. Several people are in the room, so this is great. So all of that being done, that should see NetCDF, not CF. So in the past year, we developed 3 data profiles for inclusion into the WMO data manual. There's one for marine trajectories, which could be surface trajectories like drones that are going along the surface, or underwater trajectories like gliders that dive and take measurements. There's an uncrewed aircraft system, which is kind of a trajectory, but it's a little bit different. And then there's the CF radio, which is the radial data. And so we have written the data profile, and those will be sent to the Commission for Observation Infrastructure and Information Systems, another acronym, which doesn't actually make sense, but anyways, IFCOM. And they have to approve this. And if they get the stamp of approval, then in I think November, it will actually go into the WMO data manual. And then that means that it's approved for use on the GTS and the WIS. Part of this was saying, well, this is, we're gonna do this. We're gonna exchange this data in NetCDF. So let's develop some pilot projects to actually exchange this data. So working with some folks at DWD in Germany, we developed a pilot exchange of ocean trajectory data using the marine trajectory data profile. We were looking at sail drones and AIS metadata from ships. So this is data that is also going on the GTS, but we wanted to pilot this through the WIS 2.0 services, because again, as I said, the WM wants to move away from the GTS and into this WIS 2.0. So it's a different mechanism where the GTS is, well, I won't even try to explain it, but on the WIS 2, you can subscribe to messaging queues and get a MQTT, for example, and get a message when there's new data, and then it tells you the URL to go access that data. So we developed this pilot project and it worked quite well. And one of the key things about the pilot project is to make sure that the metadata, so the CF metadata from the ships and the platforms that we're using, gets into the WMO metadata libraries. So that was very successful, and it's good. It's moving forward. So the next thing to do now, we have to actually map the NetCDF back to BUFR, which I found quite ironic, because we were trying to move away from BUFR. But the reason we did that is that, I mean, the operational community is, the inertia in there, they have their workflows that look at BUFR, use BUFR for their processes. So even if this data is coming through NetCDF, they're going to map it into buffer. They're going to convert it to buffer. And so we need to be able to map the CF parameters and attributes to the WMO variable code and descriptors, which sounds easy, right? That's not. Let me talk about something called buffer. And I want to thank Dave Barry for setting these slides because he's kind of the buffer expert. He's written some of the templates, the buffer templates that encode a lot of this information that we're putting into the netcdf files. So buffer, well, what can I say about buffer? It's a binary format that really is designed to minimize the size of the data so it has more efficient exchange. It's based on lookup tables, which unfortunately are external. They could be internal, but in most cases they're external. So a buffer subset would correspond to like a single dimension in NCDF, a DSG file, like an OBS dimension, right? And so you can see on this this table on the right, there's 4 subsets, so 4 different observations, and you can see the numerical codes. They're 0001, 0001, which means ship or land station, and you can see how they kind of map into the parameters we would use in CF. But the problem is in buffer, any given data element might have multiple representations depending how the bits are packed, right? Like, this is crazy to me, but this is the way it goes. I don't know. You know, Charlie, you got compression, you bit packing. I don't know. Maybe it makes sense. But so, for example, this is air temperature 012001 and 012101 are both air temperature, right? And the difference is how the width and bits of those variables. So the question is, how do we map CF to these specific variables? Now, that also has something called significance qualifiers, which is basically like metadata. And that's one of the strengths of buffer, which is the reason they moved away from these traditional alphanumerical codes to buffer, was not only the size, but you could also have more metadata. In practice, I'm not sure how often that's used, but it's there. So these are things like instrument type, serial numbers, quality flags. And these can be text, numerical, of course, again, using external code tables. So if you don't have the code tables, you can't read the data. That's not great. But these are equivalent to like attributes or ancillary variables in the CF, depending on how they're used. And so we have to provide the right controlled vocabulary within the data profile to ensure that it's mapped to the right WMO sequence, variable sequence. And that's going to be the hard part. So that's what we're going to start working on in the next year, is to do this mapping, particularly focused right now on the marine trajectory profile. Going from buffer to netcdf is easier, I think, because what you can do when you do that translation is you just make sure you put the code tables explicitly into the netcdf files, and so they exist in the attributes for that. Yeah, I think that was my last slide. So I'm happy to take any questions on that, as long as it's not about buffer.
How close to suicide are you?
Not as close as I was 2 years ago. No, it's been something that we've talked about within, 6 or 7 years, just at a pub. Why can't we use netcdf? It actually is listed as an exchange format that's acceptable in the WMO data manual, but it's just never been done. And so the challenge is to make CF a little bit more structured so it can fit into this operational process. Charlie.
Okay, thanks. You gave three, I guess, examples, the gliders.
Yeah.
And so in November, if things go well, will data from those types of profiles be legal to use netcdf as the source data for, but other types of profiles, no?
Yeah, basically.
So you have to kind of go
yeah,
use case by use case through all imaginable instrument types.
Well, it's kind of, I think of it as sort of the discrete sampling geometry.
Yeah.
Feature types, right?
Okay.
Kind of looking at it as feature types.
So is weather station already in that the
Would be like
list
a
of 3
time series. So it's not yet.
Okay.
And then there's like profiles are not yet.
All right. Just
We're
encouraging.
yeah. So I think time series and profiles are the 2 next on our list after we do the mapping. The mapping was not something we thought we had to do right away. And then we heard that, oh, well, we're going to have to use buffer anyway. So from the operational center. So. Alison.
It's quite a general question, but obviously you've been looking at all the very detailed temperatures all the information that has to be encoded to make those useful things. Looking at how those maps and NCDF, is there anything that you've learned that you would say makes you wish we did things in CF differently than we do? Yeah.
No, I don't, not from my perspective. It's a good question. I could ask Dave Barry because he's done a lot of more of that, but I always thought it's the other way. It's like, why does BUFR do it this way? It's so much easier to see up. It's been a personal passion of mine to get rid of BUFR. but-
Maybe following on Charlie's question, if these are kind of feature types, why is there a marine trajectory in the aircraft? Is that not a similar trajectory?
It is similar, but there are, I can't remember what the difference in the data profile was. There is something different about the altitude and how it fly. I can't remember exactly. The UAS one is based on the marine trajectory, but there's slight differences that made it unique. And we may encounter those with other as we move forward. And I'll emphasize that even if it gets into the data manual in November, that doesn't necessarily mean data is going to be exchanged to the global systems that way. There are limitations of doing this through the current GTS, the current width, because of the way that data is sent using this header and routing numbers and routing tables. It's very different than how we'll be able to do in the WIS 2.0. These will never go on the GTS. I'm positive. But the WIS 2.0, which is the evolution, which is coming up, this is where that will be supported. Did you have another question?
Yeah, thank you. Did you say that your intent is to incorporate the buffer tables as net CDF attributes?
That's the way to ensure that you have that matching.
Wow. That seems
We'll
like,
see. We haven't done that yet. So
Yeah.
we'll see what
it just seems bloaty.
it does.
If there were an extension to CF, basically, like a keyword or something,
Mhm.
like buffer.
Right, WMO.
Yeah,
Yeah.
that had a defined meaning, would that obviate always transporting a lot of buffer tables as attributes through the
Yeah.
WIS 2.0?
Yeah, I think what you would do is like add the WMO variable code sequence as an attribute and not necessarily the whole buffer table, but ensure you're pointing at the right WMO code. So
Okay.
like, to make sure that you're pointing at 012,001, so it doesn't get confused with 012,101, right? I don't know. Yeah. It's kind of a learning process. Yeah.
All these buffer codes, are there places you can go to actually resolve that, see if you've got.
Yeah.
You can actually look that up.
You can, yeah. The WMO publishes these tables. I think they're on table version number 39 right now. And if you can find them on their web pages, you can resolve.
Question in the chat. Andrew, yes, sir.
Two comments.
Yeah,
Yes,
okay.
two comments and one question. I'm interested to be shown. Yes, no, I can't. No, no puedo, Juan. What are the questions? Long question.
Oh, I gotta read it too.
I will read it. Do I read it?
I can't even see that.
Okay, fair
It's
enough.
like really
Sorry,
hard.
sorry. Just give me
Well, one was just a comment. I guess the question from Andrew Mirza at NCAS. Is any thought being given to aviation data formats that are being developed, EPW and XXM? Aviation users also be using the buffer and the grid.
No, I'm not aware of that. I mean, the aircraft one is, I don't know, if that's similar to the US. Is that similar to what he's asking? I'm not sure.
Yes, it's here, sorry.
And there's one more comment above.
Sebastian,
Yeah, that's the first one.
this is the first one, yeah.
Yep, yeah. The switching is, yeah. Buffer is great. Okay.
This is Sebastian, no? Yeah.
No, Andrew.
No.
Yeah, no, there's, I mean, this is partly why we have to do this mapping because buffer is not going away anytime soon. I'm actually surprised, a little bit surprised at how optimistic the WMO is in terms of the implementation of the WIS 2.0. Usually it's the other way around. They're not that optimistic, but they really want to really get this up and running because they recognize the difficulties of really the GTS and not necessarily BUFR as a format, but really the GTS as a mechanism is based on aging infrastructure and does have limited formats that it supports.
So at the UK Met Office, we're mapping from NetCDF to Grid 2, and we're doing this mainly manually. It's quite a sluggish process.
Yeah.
Are you planning to do your mappings mostly manually? I suppose human intervention is the way
Yeah, that's
to interpret this kind of thing.
I think so. I mean, if there's another way to do it more programmatically, I would love to
Yeah.
hear it. Maybe we can even look at some of the work you guys have been doing and that
That
can
would be
give us
great.
a boost. To put these together.
I was hoping to get some tips from you.
Yeah, yeah. Well, I'll bring that up with Dave for sure. We're good. So we
Yeah.
We're great. Well, thanks.
Another question. At least for GRIP, it used to be that there are local tables. Are these sorted now, or is it still that you can have local, the parameter, numeric parameter could mean something if it comes from this and something else if it comes from that institute?
Yes.
Is that sorted?
No, it's still
No.
the same.
That's by design, not a.
Yeah.
It's a feature, not a.
Yeah.
function.
But it leads to chaos because you're not supposed to be using global WMO distribution systems when you have data that has semantics that are local.
Yeah.
So you can use it, the regulation is you can use it, but you can't give it away basically to anybody who would be confronted with that data. You have to encode it using the WMO descriptors. But in practice, you see lots of data circulating and the GTS police are very slow in arresting people.
Right. No GTS police, yeah.
There's a working group for that.
Well, we happy to answer more questions.
Yes, undoubtedly, yeah.
So I better start by saying that what I'm going to say in this presentation is not in any way new to CF. Actually, a lot of this has been in the conventions for a long time, and it's actually something that might be a subject for another training session if people want more in-depth training on how to do variable naming in the future. But the organising committee for this workshop said, Alison, we really think you ought to stand up and talk about how we describe our variables, particularly given all this activity that's going on. And I've talked to various people in the room already today who are doing mappings and things like that. And the way that we sort of factorize how we describe our variables is different, say, between GRIP and NetCDF or other vocabularies. So that's really what I'm going to talk about. How do we do things now? And that might set the scene for some of the other things that we're going to hear about today. So, right, start off with the basics. Standard name, that's the obvious thing when we come to variable naming. And CF convention says it identifies the geophysical quantity. And very simply, we attach a standard name attribute to a variable. It's an example here on the slide. So the variable itself has its own name. And then there's the standard name. So the standard name's role is not to identify the variable inside the NetCDF file. It's to say what do these data values and what do the numbers mean if you're trying to use them. And it's very important to use the standard name hand in hand with the units attribute, because knowing what the quantity is isn't much use if you don't know what units it's measured in. So those things are always used together in CF. And I'm sure everybody here at least knows of, if they're not intimately familiar with, the CF standard name table. So this is where all the standard names that have been discussed and agreed in the CF community are published. So it was last updated in March. We are overdue an update. Been a bit pushed for time recently, so that's overdue. But in the latest version, we've got just over 4,500 different terms in there. Standard name table lists the whole lot alphabetically, so you can go and look at them if you want to, or you can search on it. And in there, of course, you have the standard names themselves. You have the descriptions, which give a bit more explanation about what what the bits of the standard name mean, how it's been put together. The descriptions aren't meant to be textbook definitions of all the fundamental quantities. So if you want to know about temperature, for example, go and read a textbook of thermodynamics, but it is meant to tell you how the name was put together. And then we have this canonical units column. Now, the canonical units is something that tends to confuse certainly new users to CF a bit, because people say, oh, well, what if my data aren't measured in the same unit as the canonical unit? The reason it's canonical is because think of it as basically setting the dimension, the physical dimensions of the geophysical variable. It should be consistent with the variable itself, and it sets dimensions in terms of things like mass, length, time, temperature, and so on. And that's the role of the canonical unit. So to answer the user question, what do I do if my data aren't in your data file? You can use another unit as long as it's consistent with the canonical unit. And this is because we have the Unidata UD Units 2 package, which the CF conventions rely on a lot. And that package has information about converting between different units. I'm sure people are familiar with this. So it means you can do things like this. So if you've got air temperature, commonly used standard name, the canonical unit, the standard name table tells you the units are Kelvin. Now, if it so happens your data are in Kelvin, then that's fine. You can just use the standard name and the units as per the standard name table. That's correct metadata. But if you've got temperature which has been measured in Celsius, well, you can convert it all to Kelvin if you want and write the metadata as before, as in the example top here. But you might not want to convert all your data because maybe that's not so convenient for your data users. So the other thing you can do is specify the units as degrees Celsius and use that with the air temperature standard name. And that's fine because UD units knows how to do the conversion. That's perfectly legal CF metadata. But what you can't do, the third example is you can't say air temperature is a standard name and then say my units are meters per second or something like that, because there is no way of converting. It's not physically consistent. So that's straightforward enough. How do we go about constructing the standard names? And we spend a lot of time discussing these standard names. And remember, what we've got to really remember is the basic philosophy behind standard names is we are describing a scientific variable. So what we write down in standard name table is meant to describe, if you like, the science and the thinking that's gone into producing that variable. And some of the standard names are quite short, like air temperature. Some of them are really quite long and detailed, and they reflect things that are coming out of climate models, for example. Climate models, you can break things down more than perhaps can in the real world. So you can say things like changes in CSIC, so changes, the standard name terminology about this tendency, just means change over time. Tendency of CSIC was due to dynamics, and that's because in your model you can write out there are various bits of the physics of the real atmosphere being represented, and you can write out what contribution each of these bits is making. You couldn't do that in the real atmosphere, of course, but so we have these detailed diagnostics. Other things like atmosphere mass content of Brox. Brox is bromine oxide. It's defined as a particular group of bromine species. Expressed as bromine. Why do we bother with the expressed as? And this again is because we're trying to be really, really precise. Because when you start talking about mass of something, do you mean the mass of the whole bromine compound, the molecules? Do you just mean the bromine in it? What do you actually mean? And somebody, if you don't say what you mean, somebody coming and using that data in 5 years' time, 10 years' time might be very confused. So we say expressed as bromine to be very, very clear and explicit. We mean the mass of the bromine that's contained in these multiple compounds. And I've mentioned already the descriptions. And these are really important, actually. The descriptions aren't part of the metadata that gets written to the NetCDF file. We always say NetCDF files are self-describing, and they are, if you know what the standard names mean, but you might want to, if you're interpreting the data, you might want to actually go and look at the standard name table and make sure that what you think it means is what it really means, because there are some definitions in there sometimes which are maybe a bit surprising. And one example I would use for this is things like sea ice. So sea ice, particularly to climate modelers, who are a big user community for CF, means all ice floating in the sea, which was formed from the freezing of seawater, rather than by other processes. And it's that from the freezing of seawater that's really important. So if you think of something like an iceberg, it's definitely a lump of ice. It's floating about in the sea. And to the casual observer, you might think, and as I used to think, that's sea ice. But actually, in standard names terms, it's not, because those icebergs were originally land ice and they broke off. So it's things like that you've got to be very careful. And when you're comparing to data variables from different outputs, if it's observations and models or two different models, you need to be sure that the descriptions you're using really match what you think you're doing. The other thing to say about the description is that the names are standardized in meaning throughout the table. So if, for example, if we say sea ice, it always means that definition that I put in there. If we say anomaly, it always means difference from climatology. And that's the same. So we try to be consistent through the standard name tables. We try to build the names following consistent patterns. Wherever we use a term or part of the name is going to mean the same thing. So the standard naming attributes and units attributes are fairly straightforward concepts. People can sort of understand how we're using them. And in some ways that's a good thing, because for people who are quite new to using CF, it can seem like an easy way into CF. I've got some new data I want to write, I've got some new variables. So what can I do? Well, I can just ask for a new standard name. And it's often the way a lot of people do interact with us for the first time as a community. Often it's the only way people ever interact with us. And maybe that's enough. And it is enough for some use cases. The disadvantage of thinking that standard names are easy, in inverted commas, is people tend to neglect the fact that there are other attributes needed to fully describe the data variable. So the standard name describes the geophysical variable. It doesn't tell you everything about how your numbers were calculated. Also, people aren't really sure about using some of the attributes. It can, if you're not careful, lead to unnecessary proliferation of the standard names. I'll give some examples in a minute. And it can also lead to the standard name attribute becoming very overloaded. People want to write very, very long standard names, describe absolutely everything about their variable. I describe it as using the standard name as a metadata dustbin. Sort of, I don't know where to put this bit of metadata, I'm going to stick it in the standard name. And that's quite a temptation for new users. And actually doing it that way means you actually have less clear and less precise and less easy to use variable descriptions than if you were to use some of the other attributes in CF metadata. That's really the kind of the take-home message from my talk today. So so I'm going to look at some examples. So the first thing is, if you've got some data in a file, okay, and this is a slide I borrowed from David from last week's training session, you've just got some numbers, okay. What does it mean? Well, you might know it's air temperature, if you've got the standard name. That doesn't tell you much else. First, well, you want some units to go with it, so it's temperature in degrees. Well, this is in Kelvin, so okay, so there's not degrees C. And where are my data points located? Well, I'm not going to have a standard name for every separate possible grid point or location on the Earth's surface. So clearly that sort of information belongs in the coordinate variables that are attached to my net CDF data variable. And that allows you to do things like plot your data and have it the right way up and not upside down or left to right and all of that sort of thing. Put a map over it. Okay, so far so good. So already we're appealing to other attributes in order to actually scientifically interpret the variable. So that's geolocation coordinates. What about vertical coordinates? Well, we don't, for example, put numerical values in the standard name because that can lead to an unnecessary proliferation, as I said. So 2 meter air temperature, for example, I know there is a grip code for that. But in CF terms, that's kind of mixing two pieces of information together. So that what the geophysical variable is air temperature. But 2 meters, the fact that it happens to be 2 meters, that's something that you would factor out, if you like, and put into the vertical coordinate. So, and the code example just shows how you would do that. So you would have another vertical, another coordinate variable, which is in the vertical, Z here, height, we know its units are in meters, and it has a value, 2 meters. So that's how you encode that information. So it doesn't go into the standard name. And of course, that's a nice generic approach. It means that if you've got 10 meter temperature or 30 meters or 2.5 centimeters or what, it doesn't matter. You can encode that information using the same machinery. And that's really important. Something else we can get from using coordinates is that they come with a whole structure of their own, the metadata that they carry with them inside an XCDF variable. So not only can we describe an individual location or series of locations in the vertical or the horizontal, but we can also describe layers and areas. So we can put bounds on our variables. So say I've got something that's 2 meters, but I can put some bounds on that in CF metadata and say, actually what I mean is my coordinate is 2 meters, but I really mean anything between 1 meter and 3 meters. And so you're actually representing not just a point location, if you like, or one physical level, which is precise, you're representing a range of values. And we actually have standard names then that work with this information. So we have standard names like the one in the example, liquid water content of soil layer. Nowhere in the standard names it tell you where the layer is. So you're then expected to use a vertical coordinate to say, well, at least where's the middle of my layer or one edge of my layer, and use the bounds to describe the extent of the layer. So we're factoring out that information again. And in CF standard names, again, we have a standard description of that. So we say a layer means any layer with upper and lower boundaries that have constant values in some vertical coordinate. It's very general, so it might be pressure, might be depth, might be sigma coordinate or something if you've got a model. So it doesn't matter what that coordinate is, but it must have some sort of constant value. Okay. There is one exception to this sort of specifying your layer or level in the standard name, and that's we do have some names for special in inverted commas levels. So, for example, surface temperature. And standard name surface means the lower boundary of the atmosphere. We've got cloud base height. And troposphere. Troposphere is a layer rather than a level. The thing about these is we do have a kind of conceptual idea, if you like, of what we mean by the lower boundary of the atmosphere. Everybody kind of understands what you mean by that, understand what we're trying to say. And it's not constant in some vertical coordinate. So we can't use the numerical layers or level descriptions. We do it in words instead, and so that is an exception to that. And again, we can have layers, levels, or layers by that method. Talked about coordinate variables in geospatial sense and in terms of height and time, of course, it was an important coordinate. But again, something that I've seen people ask sometimes in the CF discussions is, can I use a coordinate variable if I have a dimension that's not geospatial? And the answer is yes. I mean, it's completely fine in NetCDF. It's completely fine in CF. So say you have something that's been observed, like the example here, atmospheric optical thickness. And there you might have observed that as a number of different wavelengths or frequencies from satellite, for example. And the way you can describe that is by using a coordinate variable again. So you can create a coordinate variable and give it a standard name of radiation wavelength. If you look through the standard name table, you can see a number of standard names are basically flagged up as being used as coordinate variables. So whether it's height, depth, or radiation wavelength, there are others that are basically have that role in CF. And if you were to look at the description of the optical thickness name, you would see in the description it points to you and says, unless you give a radiation wavelength as an additional coordinate variable, I'll assume you mean all wavelengths, basically across the spectrum. But if you want to specify a wavelength, you can do. So it sort of covers all the cases. Some of that's described in the description. Some of it depends on what coordinate variables you attach. And so, as I've said, sometimes there's a temptation, particularly when you're grappling with quite a complicated variable, to try and stick everything in the standard name. This does come up quite often. But we can do a better job than that. And that's what this example is meant to try and illustrate. And this is probably a real case that we've been discussing fairly recently in the committee. So we've got an existing standard name, standard name called CI thickness, and the canonical units are meters. That all that's fine if you're just measuring CI thickness at some general location. But this particular data variable, I'm assuming it might have been a model variable. What we actually want to represent is we want to categorize the CI a bit more and say we want to measure CI thickness only where the CI has a particular age, like first year ice, multiple year ice, and so on. That's quite complicated. And so we could say, well, let's try and stick that information in the standard name. That's the first port of call. And we could define new standard names, things like thickness of first year sea ice, thickness of multi-year sea ice, and so on. We could do that. So we'd have yet more standard names in the table. And again, we'd be proliferating quite similar names. And it's then we've also got to ask ourselves the question, if we're going to write the description of these names in the standard name table, what do we mean when we say first year sea ice? Does that mean between 0 and 12 months old, between 6 and 18 months? What does it mean? And does it always mean the same thing in everybody's data sets? We've got to sort of cover all those eventualities. And similarly, what does multi-year sea ice really mean? And might we have more than one value of that? So rather than encoding it all in the standard name and writing a description which is sort of set then in the standard name, we can do better. And again, we can add an additional coordinate variable. We already have a standard name, which is age of sea ice. And if we use that as a coordinate variable, we can put our values. So we can use our existing sea ice thickness name, and then we can encode whether we've got one age of sea ice or 20. We can put them as a dimension on our sea ice thickness variable, label them with a coordinate variable, and we can specify, again, values just as we did with the other coordinates, and we can put bounds on it. So we can say year-old sea ice means between 6 months and 18 months. We can encode all that for free just using the coordinates attribute or metadata element, if you like. And so that's using coordinates in particular is a really powerful mechanism of breaking down your method. It needs a bit of sort of lateral thinking, if you like. How am I going to split up my variable? But it means that I can encode all that extra information much better than if I try to write a long sentence in the standard name, and then it would be quite difficult to parse. And what order do we write the different sections in? We don't have to worry about that if we use this. So that's one example of using coordinate variables is a really useful thing to use alongside standard names. There's other things we can do. There's other pieces of CF metadata, other attributes. So one example is if we want to describe the statistical properties of a data variable, we can use something called standard name modifiers. These are not used a lot, but there are certain pieces of information that we might have about how our data were obtained. So say we've got temperature and we've got a particular number of observations that contributed to that value. So some measurements in some places might have been formed from dozens of observations. Some might only have 1 or 2 because there are gaps in the data. We might want to know about that. It's kind of quality control information almost. And what we can do in CF is if we've got that information for all our grid points, we can construct a second data variable, which has the same grid as the original data variable. And this is called an ancillary variable. And so we have one piece of metadata for every grid point in our original data. We can connect the two together using an ancillary variable attribute. So we say this data variable is linked to this ancillary variable. And then we can, what's unusual about the ancillary variable then is that we give it a standard name, which is because it's information about air temperature. We say it's air temperature. And this is the only time you'll see any white space in the standard name. So in that very narrow class of instances, we'll say air temperature and then a space and standard error. And that the thing that comes after the space is one of these values chosen from the list of standard name modifiers. So we don't use them a lot, but there is that there if it applies to your data. There's other ways we can describe statistical sampling and post-processing. It's a very powerful attribute called cell methods, and we can put an awful lot of information into that. Works very well with things like climate indices. And Antonio showed a brilliant example last week in the training. But it can also have simpler uses as well. So there are actually these cell methods are all listed in Appendix E of the conventions document. There's actually 17 of them, and I just picked a few out here. But these are sort of statistical post-processing or sampling type things. So you can have a point observation or a mean. It could be an area mean if it's come out of the climate model, for example, or it could be something post-processing. So you had sampling every 10 minutes and you meaned it over for an hour. So those are the sorts of things you might want to describe. Max and sum and all of these things that you would associate with statistical processing of your data. And again, rather than having lots of CF standard names where we say air temperature, and then mean of air temperature, and then sum of air temperature, and we could have all these standard names, but we could do that for all the variables. Instead, we just have, again, we use air temperature, if that's our example, if that's our geophysical variable, we stick with that, and we provide the extra information by adding a cell methods attribute to our data variable. And so it might look something like this. So it's an example here. Again, it's air temperature. And the great thing about cell methods is, again, you can give much more description than you would if you just stick everything in the standard name, because you can do different things on different axes of your data. So, for example, your original data might be an area mean. Say it's model data, might represent an area mean. But maybe you took the maximum values over a period of time, and you can specify that. So you can have this sort of structure where you say area, mean, time, max, and you can list all the things that have been done. And that's how you actually got those numbers. So then when you start to compare them to other data sets that may not have been processed in the same way, you start seeing differences. Maybe it's because of the way you processed it, rather than a fault problem with your model. So it helps to answer all those sorts of questions. And the rule is that the order that things are listed in cell methods attribute is the order that they were applied to the data. So the mean of the max may not be the same as the max of the mean, and so on, but you can list all of those operations that you did. So you're really preserving the provenance of your data, everything that's happened to it, and that's really useful. You can also use cell methods. I won't go into this in detail because it gets quite complicated, but we can use it to look at statistics for the portion of the grid cell. So often it's the case with land surface models, you'll have your model grid cell, or it may even be true if you're looking at satellite data. You've got a large satellite scene, but in that area, there will be different types of surface characteristics. So you might have ice, you might have open sea, you have land, trees, whatever. So you can describe those characteristics. And we actually have a vocabulary, another list of terms called area types, which is separate from the standard names table. So we can see, you can choose again from that list to describe what type of surface characteristic you've got in this metadata. But you can, again, you can do things with your cell methods attribute, where you can say area, mean, where, sea ice, and where is one of these special code words. So it means I'm going to, and this time I'm looking at surface albedo, that's my characteristic, and then obviously it will be different between sea ice and say open sea. But I want to know what's the mean sea ice albedo only over the sea ice, what's my grid cell. And so I can apply this method and say, this is what I did to my data. That's how I got my numbers. So that's yet another example using another CF attribute besides sticking it in the standard name. Then there are some things that we can't necessarily separate out. What if we can't fully standardize the description of a scientific variable? I've got an example here. There are some things where the scientists who are producing the data don't completely agree, or they're running different models, or they've got different observing methods, and it doesn't necessarily, the results aren't completely standard from one group to another. The example here is mass concentration of alkanes in air. Everybody knows what an alkane is, so it has a particular chemical formula, CnH2n+2. That's fine, that's an alkane, but apparently, so I'm told, different modeling groups represent different numbers of these compounds when they run their chemistry models and so on. And some people might say have the first 5 alkanes, the lightest ones, represented as separate species in the model, and then they lump all the rest together. So they all have a similar chemical formula, but they're not accounted for separately. Other people do things differently. So the truth is that because we can't tie the science down, then we can't use a standard name to tie it down. That would be false, if you like, giving false precision or false certainty about what the data is. So what we do then is we ask simply, we make the standard name as precise as we can, but this is kind of deliberate vagueness here. So we say we're just talking about alkanes, we know what they are, but then in the standard name description, it will say, please, where possible, put a comment attribute on your variable and say what you actually did. Because what you did might be different from what somebody else did, and we don't know what you did. If you want your data to be useful to other people, please just tell us. And there are places where you can do that in the CF metadata. So again, we're following the science really by doing this. So just to summarize then, there are some things that are definitely not described in the standard name. So vertical level, geolocation information, because they go into coordinate variables, or there are region labels. If you've got a region like, I don't know, North Atlantic, again, there's actually a controlled vocabulary like a gazetteer of regions which don't have square grid boxes, if you like. It can be strangely shaped or sized regions. Statistical processing, cell methods attribute is your friend there, do make use of it, and proportions of grid cells. And of course, the units attribute, whenever you're using the standard name, or even if you're not using the standard name, putting the units attribute in is going to really help your data users so they can understand the numbers inside your variables. And that's what it's all about in the end. That's what the metadata is for. So we can avoid this kitchen sink approach, putting everything in the standard name, please. No more kitchen sinks. That's it. Quick rundown.
There's one question in the chat, I think, no? Just in case there is somebody asking.
Thanks.
That was really great. I learned a lot. For that one of the last examples, you said that couldn't fully describe the specificity of the, you say add something into the comment or something like that. I was if we're doing this for machines to understand the data, that seems like it wouldn't really work.
That's kind of a limited. I mean, I guess this is where you might come down to doing things like on a project by project basis. So say you're sharing data with a known group of people who they may say, well, we'll use another attribute, which you're allowed to do. Of course, that's legal CF. And you can say, well, for our project, we'll call it, I don't know, CMIP alkanes or something. And so people will know what it is. And you can have a list there. And then you could consume that in the machine as well. But for the general user, and in the absence of those project by project, then at least what we've got there is you've got the information so that if somebody comes along in 5 years time, 10 years time, 50 years time, wants to look at your data, they can still at least work out what's in there, even if it's a bit hard work. At least you've not lost the metadata, and that's kind of the idea.
There is one question from Andrew Barna.
Another thing is in terms of dimension analysis. Should we? I guess that's one way we've always done it as a canonical. I think the point about having things in the canonical unit is it works with the UD unit software. So I explained that we've got this Unidata UD units 2 software, which basically it has in there a set of units that it understands. So the canonical unit will certainly be on that list, and other equivalent units like Kelvin and Celsius and so on. Like, I don't know, miles and nanometers, it could convert because they're on the same physical dimension. And if we were to start going on to dimensional analysis, I don't think UD units as it stands would cope with that. So we'd have to go back to the developers and say, please, can you start processing it? I mean, it's not saying we couldn't do it. It would be a scientifically good solution, but maybe not so practical from the point of view of the software. That's all I would say.
Yes, I have a comment and question. The first part of your talk is very interesting because you are explaining that the standard names are not a thing of putting everything. It's just, and I think it's something also very useful or could be very useful for the training sessions, for example, to try to explain that, because the people tries always the time just looking at the standard names table because it's separate from the, I mean, it's split from the document, because there is no, it relates to my first question to David about it, because the document is too big, because if you go to the convention document and you see the convention document, say, I'm going to read this. Yes, prefer going to the standard name, and they can. And then how you were putting example of using coordinates, for example, because coordinates is very useful attribute, for example.
Yeah.
But the problem is, I think we need to put more emphasis on this and more examples, and more on training session, just to show that. Of course, the same methods are.
Completely agree. Yeah. So as I said at the beginning, I think this talk is something I might even think about making into a video and adding it to our YouTube channel. And it's something that's there for all time for people to watch, basically, because if I'd done this talk 10 years ago, I would have said pretty much the same thing. It hasn't changed. It's just that always there are new users coming along. And when somebody's new to it, and like you say, they look at a 200-page document, and then there's 4,000 standard names. All right, there's quite a lot, but it's just easy to get your head around. So people go the easy route. And that's actually a problem in the end. So we don't get the best metadata from doing that.
It's also one of those things that you really only need to be told once on your way in through the door of CF. Hopefully. Oh yeah, obviously that, you know, sometimes. But I mean, you know, things like the canonical unit. I bet, well, I'm going to show you why I asked this question. Everyone asks that question. Once you've been told it, you know, that's it. You don't need to know it.
Yeah.
So a lot of this stuff is purely introductory, and then, as you say, hopefully, once you've been told it, you're in.
It is. I mean, in terms of, we were talking earlier about a core set of metadata.
Yeah.
It's standard names, canonical units, coordinate variables. I mean, that's core CF, or even core net CDF. So really, that's been like that for longer than I've been doing CF, so it doesn't really change.
Okay.
Sorry.
I think the standard name update and introducing new standard names, that process works. It's quite operational. It works just fine.
Okay.
But how about getting new cell methods? It seems to be much more fixed.
It's interesting that I mean cell method with, like I said, we've got there are actually 3 bits of CF that are managed formally, if you like, as controlled vocabularies. There's the standard names, the area types, and the region, and those are all pushed down sort of the same management route. And then things like cell methods, you could say, well, actually that's a controlled vocabulary, but it's a bit more than a controlled vocabulary, because there are also these different usages of it. So for example, things like the parts of a grid cell and the time processing and something. So we can manage it as a vocabulary, but I think often there's more discussion around that, and it does have a bit of a wider implication than just what we're going to call it. So I think that's why that tends to sit in the conventions, and other things tend to be separated. But I agree, it's a bit of a fuzzy line.
And the second question is if CF decides on a sort of set of standard names, like this starting with C something, it's a current issue. And then it's supposed to be both freshwater in sea, context of sea, and then also saltwater. And then there is another commune coming in saying, well, we want freshwater separate. How does this sort of...
Okay, so I know this debate is happening. It's a bit
issue,
stuck.
yeah.
It's been stuck for a while, and it just sometimes I don't quite have the energy to do these things. But I mean, my own theory is actually we should allow all the use cases. This is where you might actually allow some redundancy. So if it's C, and you really need, to my mind, well, we don't have a definition for C in the standard name table. There's never been one, but I think what we mean is the open ocean, the oceans that are connected to the global circulation, and that doesn't mean an inland sea or a lake. And we know what we mean by freshwater, because it means salinity is low or negligible. So, and there are times when you might want to treat those separately. So I think we should allow, this is just my opinion, I think we should allow separate standard names. Then you will get data sets, and somebody gave an example of them where actually you've got a ship, it's gone on a trajectory, it started off somewhere in the North Sea and it's sailed through an estuary and up into a river. So it's actually crossed between different. So then you would have to have a more generic one, like water body or some, you know, I'm sure we could eventually hammer out stuff. And yes, that does mean that in some ways you're duplicating things, But I think it's the easiest way of giving everybody what they need so they can get on and write their data. And as long as we clearly define what we mean by it, and C, I think, doesn't mean puddle or river or whatever, which some people try to argue it does. We have to write, I think we need to write those descriptions actually. I think that's part of it. But other people will then probably come along and disagree with me profoundly. So that's still an open question right now. So how we do that.
Kevin, the rest of the so any comments? Thank you, Ali.
Okay, so this is a slightly different title to what we were given, which was Standard Name Challenges in the Carbon Community. It's very early days for the carbon community, the ocean. This is the ocean carbon community as a whole. So I've kind of been exploring a bit of this standard name stuff over the last year or so, and kind of as I've been doing that and getting into it, thinking about how it will then be applied to wider aspects of the community and also into efforts that are already going on, because, you know, we're trying to standardize all of our metadata and all of that kind of stuff. So I'm going to kind of start with my own adventures in this and what I've kind of found, what I've discovered. A lot of this will be relevant for you and probably Sadie for the training stuff. This is, as I say, mainly what I've discovered. A lot of it I haven't kind of followed up in any kind of detail, questions I haven't asked, that kind of thing. But just to give you an idea of kind of a new person coming in, what sort of things, obviously a lot of you will see this before, but it could be, yeah, it could still be useful. So I'll do that. And then at the end, I'll kind of summarize where the wider carbon community sits. So I started this because I was kind of in the ocean around Europe. I started with kind of the BODC, P01 vocabularies. And I've kind of been expanding towards the CS standard names as we go. So a quick bit of background. Where I sit, we have a lot of sensors in the sea that are measuring data. So my main part is in the second thing with the weird fruit, which is processing data and quality controlling it. Now I've been thinking we should get standard names in as early in the data flow as we possibly can. So that's why I've been starting to look at it. But as that data gets published into data centers and then into wider data products such as SOCAT, which is the global surface CO2 database, obviously they get more out into the outside world and the standard names become a lot more important. So that's kind of where my focus is and where I started. For my own bit of the software, nothing really goes outside, so I could just put in a standard P01 code into my database, and that will be good enough for me to track it. FCO2 XXXX is what the P01 code is. For the data center I mostly work with, they have this kind of ontology where they describe their data sets. It's very well written and very well put together, and all the data sets are fully described in the metadata. So we have this thing where, you know, I have my data format. It has this column called FCO2 UATM. That is defined in the data center. And then there's this whole hierarchy of relationships. So it says, okay, so this is a column type of FCO2 in general, and that column type has a column code, FCO2 XXXX. So this whole kind of hierarchy of how you get from the data to the code. So it's not NetCDF stuff, it's not all buried in the files yet, but it is there in the metadata. So, as I said, mostly I've been using P01, but I have looked at CF names, and obviously part of this was working out what name I should use. So I did a search in the CF standard name table, and I found fugassity of carbon dioxide in the seawater. Sweet, done. Let's have ice cream. Finished. For P0, that might not be true, actually. We'll come back to that in a minute. For P01, I did a search for FCO2, and I got FCO2 XXXX, which is the fugassity of carbon dioxide, 100% humidity, yada yada, in the water body. Great. I also found FCO2 TKO2, which is fugassity of carbon dioxide in the water body by equilibration in air, drying and constant temperature, you know, all that kind of stuff. This is obviously P01 has a slightly different philosophy to CF in terms of the metadata sync. There's an awful lot of stuff in there.
And I was thinking that's massively overspecified for what any kind of user would want in terms of just finding data. It turns out there is some logic behind this because it's built from little chunks of definitions. They may not be the exact chunks, I just kind of did it exactly. So there is some kind of logic behind that. So you can see that if there were the things done by other methods, you could build up a new code. Whether the method of measurement is of interest to end users, in a lot of cases, it probably isn't. Sometimes it will be. Where that boundary lies, obviously people make different decisions. I have my own opinions on that, but clearly more experienced people than me have thought about this, so we won't go into it. But the problem we have is that then, we have multiple FCO2s and how we use them. So again, I chose the generic one for my work, FCO2 XXXX. One of the main reasons for that is that if I decided to have, if we get sent data in from different sensors, from the infrared dispersal one that I've just shown, we'd have FCO2 TKA2. For something that used a membrane in terms of its sensors, we might have to make another code FCO2 membrane. So we then end up with two entries in the ontology at my data center that I'm sending all this data to. And obviously, if given the level of detail that went in there, you could end up with 8 or 9, which kind of becomes unmanageable fairly quickly. So I stuck with kind of the generic one, which could work. Those, we've got our 2 ones, FCO2 XXXX. I just use that for everything. Things could be okay. Also, there is another level in the P0, the NODC vocabularies, which has a kind of broader focus. And all of these things are basically members, subsets of PCO2 in a different vocabulary, which again, perfectly reasonable. And there's a hierarchy there that you can follow. Unfortunately, where things fall apart with that approach is we also have another FCO2, which is FCO2 EQ2X, which is basically exactly the same, except it's not at in-situ temperature. So as an end user for FCO2, the chances are you don't want that one. So if we have a bunch of data in our files with FCO2 EQ2X, it's pretty easy to mix them together. And of course, if I decided to just, let everyone search on FCO2 star, I would hit this problem because FCO2X is still part of that. And interestingly, it's also registered as part of that big PCO2 thing. But EQ2X is not equivalent to those other 2. So you need to be incredibly careful how you put this stuff together. And that's why I think it's important for CF to be aware of this, because when there is a mapping or there's a mapping effort going for P01 to, if you just map FCO2 everything to fugacity and seawater, you're going to end up with things like that in there, which are going to cause some issues. So yeah, just things to think about, more explorations. A few random thoughts that I've had while I've been doing this. As it's been said 3 times already, I'll say it again. I hit this problem. It says down here, caloric units, pascals, what the heck are they? There is a big spiel up there, but you're on the internet. That distance is basically from here to the moon. No one's going to, no one reads that. So again, as I said, it's one of those things you get told it once, you don't need to know anymore. But it's obviously something that he's looking at, whether you could put a little, little question mark helpy thing down there, so people can just click on it where they're looking, and then it pops up and tells you what's going on. I don't know, but yeah, I'm fully prepared to admit I'm as lazy as everyone else, so that's fine. Should there be terms for everything? I know standard CF says not, and it's quite acceptable to have things that aren't in there. But again, if you're thinking about mappings and there's things that just map to nothing at all, is that fine? There are things, like when I'm calculating FCO2 from the raw measurements, there's various things you calculate on the way, like water vapor pressure, that basically no one's interested in, but we sometimes put it in our files just for completeness. For provenance and all that kind of thing, should they have names and codes? Maybe not. Maybe you put something in there as a placeholder, probably a bad idea, but I bet someone has done it. or we create names that are of questionable use. I don't know how you'd put it, but they may be of use of someone, they may not. It's acceptable not to have them, but I'm just kind of interested in where that line gets drawn. And obviously with this whole carbon community coming on board and trying to do this, there will be a lot of these kind of questions that come up. So it's something I'd like to know, as I say. Another issue with mapping that's just gone through my head, which again, probably less important for CF, but I just thought I'd bring it up anyway, because there are some BODC people around. We're starting to look at using this device catalog, which is a vocabulary that BODC developing to have a list of all of the instruments that people use to measure stuff. So you can link that direct to your data and you can go back. To an extent, that would remove the metadata dustbin thing of having that enormous string saying what everything's in, because if you link to here and here, it will tell you exactly what the instrument did, which is brilliant. And at the minute, there's one there, tool 724, which is General Oceanics Measuring System, which is great. And that system measures FCO2 in the way that the P01 code says for TKO2. It's got that huge long string, it does gas infrared technology with equilibration with air and all the rest of it. Brilliant. If I add another sensor, this Oceania CO2 system, that uses a membrane. So it would probably use our hypothetical FCO2 membrane code that we created. The problem is that that data then cannot be linked to a column that says FCO2 TKO2. They're incompatible, because the method of measurement, because it's built into the code, is not, they just won't match up anymore. So if you're starting to look at things like this, how do you enforce that? Should you enforce it? Because there becomes a point at which your metadata and your data actually become internally inconsistent. Anyway, just a random thought for the non-CF people. But CSV files, moving towards our kind of wider community and our data centers, pretty much all of our data at the minute is published as CSV format. So putting in all of these standard names and units and all that kind of stuff is an eternal struggle. Maybe we should use NetCDF, maybe we should be using something else, who knows? We talk about this, someone stands up and says, well, you can't do that because I can't, it won't work with my Excel template anymore. So, that's the end of that discussion. But there's a few issues with that. CS files are obviously easily separated from their metadata. Even in our data center with that amazing ontology and all that kind of thing, once you've actually downloaded the CSV file, you're done, it's gone. So how do we label our columns? We just use a code, nobody can read it as a human. Great for machine-to-machine stuff. The thing we tend to do at the minute is put a name and the units in there, but again, it's not a standard name. Maybe we put in multiple header lines, but I do like the look of NCCSV, and which appears to be it's a NetCDF compatible CSV format in effect. That's its aim. I'm just kind of curious how widely that is used, how widely that's understood, and whether those, whether there are libraries that read those kinds of things or can convert between them. It's something we need to think about, but I just thought I'd bring it up here because there are those people who will use the standard name side of things, but not necessarily figure out how to put them in the CSV files if they're not using that CDF. So again, potentially something to think about. And it may be you already have thought about it. As I said, I'm totally new here and you're just sitting here going, yeah, obviously. But just to finish up with the state of our carbon community, historically, we've had global databases called SOCAT, which is for surface CO2 measurements, and for GLODAP, which is for an awful lot of carbon-related measurements in 3D space, right down into the ocean and all that kind of thing. These are feeding into things like the Sustainable Development Goals, which I forgot to put on here. They're 14.3.1 is it, ocean acidification. They're trying to get a standardized data set for all that level of research, and they're working on their metadata systems right now. So this is the point at which we need to start thinking about putting these metadata systems in. I said there's nothing in place yet. It's not strictly true. We are building standard metadata tools and all that kind of thing. And we are starting to talk about these, using these vocabularies, what we should use and all that kind of stuff. So we're at the, not quite at the very beginning of those discussions, but fairly early on. We have a fairly large case of not invented here syndrome going on, where, you know, people look at this, they come in, search standard names, they go, well, that doesn't quite look right. The canonical units are weird. There's something to do with chemistry and molds and all that kind of stuff that didn't quite match up with their expectations. So I just go, oh, this doesn't work, let's build our own. Yay, we've got another standard. We've got to try and map it and all that. So we'll try and stop that from happening. But, you know, those are discussions you have in these communities. But we do need to start taking it all seriously. But all of these, I should mention that there are other efforts on the way trying to kind of emulate the SOCAT and GLODAT thing of building global databases for oxygen and pH and all sorts of things. So obviously they need to come in on board. But yes, it's a subject we need to start taking seriously. And we need to work on our vocabularies and our data formats to make it happen and make it more machine readable and standardized and all the rest of it. So yeah, that's kind of where we are and what I've done so far.
There is no question.
Okay, yes. I saw you did the questions.
No.
Yeah.
Okay, I don't know if this is a question or my own ignorance being exposed here, but
I'm just up here to expose my ignorance, so yeah.
I think you're talking about whether the measurement method should be renamed. Just eavesdropping on standard name discussions. I think it's the case that we tend not to in standard names. Things are often simulated. You want to find the observations to compare the simulations.
Yeah.
As though that's sort of.
Yeah, I mean, those.
Well, I agree that it's actually to try and avoid saying that just because something is measured by, so you've got a thermometer and a temperature curve, you're still measuring air temperature, and you actually want to compare them. They're not, but it is useful metadata.
It is definitely usable metadata. It's just a case of where it lives. I think it's. I mean, I can see kind of why P01 has it, because if you go back to think about like measuring sea surface temperature, like in those days when it was done by yanking a leather bucket full of water out of the sea and sticking a thermometer in it, you need to know that quite early on in your data processing, because it has a huge effect on what your answers are going to be. For this stuff and for the kind of stuff that CF is doing, probably not so much. So that's.
Do we need a new measurement type attribute? I didn't say that.
Yeah.
Oh, right.
Yeah. But I mean, yeah, it's a big old can of worms. Alison, you actually had a.
Oh yeah, it was about the CSV format. I've not heard of NCCSV. Who's working on that? Do you know that?
Kevin, I believe, knows more about it than I do.
Yeah, that was a format that was kind of developed by Bob Simons, who developed BirdApp, and it basically is CSV, but in the header, you are to use NCF attributes, standard name, units, that sort of thing. And so partly he did it because what his software can load in data set in lots of different formats, and metadata becomes an issue with CSV. But if you do it properly in CSV, when you load it into the software, it's fully documented, all the metadata is there, and so it acts like a well documented. It's a self-describing file basically, but it's CSV format, so it can still be written in Excel and all the other CSV tools.
I'd be interested to look at that because I actually know the different code, which is the BADC CSV, which was invented at CEDA. Which is exactly the same thing, and it just uses the names, but there's still restrictions on being able to put dimensions on things.
Oh yeah, absolutely. It's I don't know if it's going to be the right answer. It kind of feels like a stepping stone to doing it properly in CDF in many ways, but and whether we go with it or not, these are just, as I say, thoughts going around in my head. I haven't spoken to anyone about them yet, but it's.
I'll throw the NCCSV spec document into the folder.
Yeah. Yeah.
There's one comment in the chat.
Yeah, there's one comment in the chat.
Sorry.
feelings review of what haven't used line 7. Sure, if you want to take that on, go for it. But yes, it's one of those efforts of mappings and just maintaining these things. And as I say, I'm in no position to tell anybody what's correct for any specific vocabulary. They're just kind of mismatches I see as I'm going through all this stuff. So obviously, yeah, there's a huge amount of work that goes into this, and I'm incredibly grateful for everyone who does it. Hopefully, I'll, you know, as carbon comes in, I'll start to be a bit more active in it. But yeah, it's a big old job. I'm not going to deny it.
Okay.
Kevin, you have half a hand up.
Well, it's just a comment because, you know, I'm really glad that you came here to talk about the farming community and some of the struggles. And I think, you know, what we're dealing with is sort of like scientists who want, you know, the variable names include the units and everything, so it's really clear when they see it, and not really understanding how we can use attributes and Excel methods and sources to further describe the parameter that has a particular standard name. And how those two can meet. I don't know what the best way to do that is. And
Yeah.
they get frustrated and they say, oh, it doesn't work because it doesn't, like, it's all dead organic carbon. There's like 4 different definitions that confuse them, all of them. So I don't know, how those got in there or when they got in there. But it seems like that's an example where there needs to be more clarity on how to create.
I wish somebody from that community would come and talk to us, because I don't like all the different definitions either, but somebody gave them to me and they ended up in the name table,
Yeah.
and I'm not a chemist, so I don't know. I mean,
Right.
I would love somebody to come and help me sort through those and
Yeah.
make sense of them.
That's why I'm here. I'm trying to make that bridge, and Steve is hopefully also very sees
Yes.
as well. So, but it's the challenge of how to educate the community.
Yes,
Maybe
absolutely.
it has technically savvy. Even the data managers not necessarily is technically savvy to understand how to properly describe a variable in CSIC.
Yeah.